All right, so we're going to go ahead and move on now to objective two, which is to calculate the mean. And there's a couple of things on this first slide that um, we're going to look at and we're going to discuss as we kind of move further into stats. But the mean you should have done before. It's just the average of all the data values. But we can look at this and we have what is called X bar, which is the sum of all the values of data. Okay, divided by the total number of data values. So the mean is the average. All we're looking for is the average of all of the given data points. Okay, and again, kind of looking at this notation, this X bar, okay, this little X with a bar over it, we call it X bar. Okay, and all this means is it's a sample mean. Okay, sample mean, which means we're given a sample of data and we find the mean. So as we kind of get further, we're going to use X bar quite a bit as we get further into potentially chapters 6, 7, 8, and 9, I believe, or 7, 8, and 9. We're going to use X bar quite a bit. Okay. Now, just another way that we can look at this formula. X bar is equal to X1 plus X2 plus dot, 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 Xn. That takes us all the way down to the total number of values that are in the data. If we have 100 values of data, this X to the N would end at 100, okay, and we would divide by 100 here. So this symbol right here, okay, is called the sigma symbol, and all that it means is the sum. Okay, so anytime you see this funky looking E thing that you might see on a fraternity or sorority, it's a sigma symbol and it just means sum. But we're just going to look at the average of values here. Okay, so we're going to look at the average. We're going to take a look at an example here, just find the mean of given data. And we're going to talk about what happens when we have outliers. So how high is the score? How many runs does the Lawrence High School baseball team usually score? The dot plot displays the data on the number of runs scored by the team in all 21 games played during the season. The dot plot suggests that the game in which the team scored 12 runs is a possible outlier. Calculate the mean with and without this outlier. So we're going to go ahead and put all this data into, once again, when I put this into my stats app, okay, we want one quantitative variable, and we're going to enter all the data. So take a picture of this. They scored 0 runs. They scored 1 3 times. They scored 2 4 times. They scored 3 3 times. They scored 4 twice. They scored 5 twice. They scored 6 twice. They scored 7 once. They scored 8 once. They scored 10 once. And they scored 12 once, which again is our possible outlier. So when I begin analysis and we go down to looking at this, good, I have 21 pieces of data. There's my N. Okay. And what is the mean? The mean is 4.143. So if I go back to my data, the mean with the possible outlier, okay, so I'm just going to put 12, which is the possible outlier, was 4.143 runs per game. Okay, if I go back to that stats applet and I get rid of that last data, we take a look at what happens to the mean. What do you think is going to happen? If I take away the largest value and then divide it by, now we're not going to divide it by 21, okay, are we going to, what's going to happen? Get out of there. So begin analysis. Let's see here. Where are you at? Back to menu. I'm messing up. It's not moving for me. Let's see. I got all this data here and I want to begin analysis. There we go. My bad. And I now have 20 sets of data, but as you can see, the mean went down to 3.75. Okay. So the mean here is 3.75. The mean without the 12 or the outlier was 3.75. So you can see it went down. We got rid of the possible outlier and it clearly went down. So hopefully that makes sense. So again, if I ask you to explain it, we've got to make sure we use the language when the possible And why am I saying possible? Well, this is only 21 games. What if they played 41 games and they scored 12 5 times? And that wouldn't be an outlier. Okay, but with the given data, the possible outlier of 12 was removed. The mean decreased from 4.143 to 3.75 runs. And when you guys are making this, what do you notice when you're explaining it in words? You could have also said when the outlier was included, the mean was greater, 4.143 runs, then when it was removed of 3.75. So just make sure that it makes sense when you explain it. Okay. So now we have to take a look at this, and what does that mean as far as the mean and the median? Okay, so a couple of very important things here. We're going to talk about resistant. Okay, very important vocabulary word. Resistant. Measurement is not influenced by unusually large or small values. So again, not influenced by what we call unusually large or small values. Well, what are those called? Those are the outliers, right? So the median is usually not affected as much when we remove one of the outliers, but the mean is not resistant, meaning when I take away that larger or smaller number, it's going to change that mean value quite a bit. So the mean is not resistant, and the median, okay, usually is resistant. If I just move one or two of those values, that value in the middle normally stays very, very close, or it is the same as what it was without moving it. Okay, so objective 2, calculating the mean.